You don't have to wait. You can just put it in. All right, you guys have been playing on this problem since the beginning. Quick recap for anybody who's gone today is, or watching this at a later time. Okay. Shh, you've had time to collaborate. My turn to play. I'm going to let you talk a little bit more if you guys think you need it as far as this problem. But I'm going to start playing. I'm just getting everybody caught up, whoever might be watching the video right now. You guys were working on this system from yesterday, asking yourself the question, does anything weird happen? And then when anything weird did happen, going back to the page from yesterday where we talked about consistent versus inconsistent and which category this falls under, and as a result of which category it falls under, what kinds of answers are we looking for? One, infinitely many, or none? Here we go. The very first part, you guys help me by reviewing the system. What's the system say to do? Wait, why are we doing systems anyway? We're creative. We can have our own creative approach to a problem, maybe get there faster and easier. Because we're trying to think about computer programming. A non-creative machine needing to follow the same step-by-step every time to solve every system, regardless of whether two random numbers happen to match with one being a negative. In this one, yeah, R1 and R3, Gavin was saying, like, couldn't you do R1 and R3? And I totally agree, but would a computer know that? Now, there are different, like, conditional programming. We can say, if you're given this, then this, and if you're given this, then this. Like, yeah, you can do conditional, but what are you going to say to it, computer? If you have a 2 and a negative 2, then, but wouldn't you also have to say, if you have a 3 and a negative 3, then, if you have a 4 and a negative 4, then, if you have a 162 and a negative 162, then, that's not good programming. It's general and give general steps that allow the program to do the exact same thing every single time and get the desired result rather than doing all these conditions of, ooh, if they match. All right, so the system says go for eliminating. Who first, though? What was the purpose of R1 and R2? We're trying to get rid of X. So the big category of the first step is to get rid of the X variables using R1 and R2 and also using R2 and R3, right? Do you guys agree with the system? Okay, so then hopefully you guys were able to. Now, I allow you to be creative because you're not computers. I'm not making you totally be a computer yet. So I allow you to look at these two and say, how can I eliminate? Oh, hey, I can make this, that, by multiplying and opposite by a negative 2, right? So hopefully you guys pretty quickly got a negative 4x. Double check my math. Another good reason for me to have you guys go first. Minus 2y plus 6z equals negative 8. Have you guys ever been like trying to do something and talk about it at the same time and everything gets like wonky? Either you start doing it wrong or you start speaking it wrong. Life of a teacher every single day. Anyway, so multitasking, it's hard. So 4x plus 2z equals 10. Maybe that allows you to have a little more compassion when a teacher says something, you're like, I don't think that's what they meant to say. Because they're trying to look at, thank you, classroom management and figure out who's lost and who's tracking and who's able to answer the next question and who's like needs just to go stand up in the back of the room or who needs to go get a drink of water or who might be like bleeding in the corner because they just cut themselves with their pencil or who. And that's just like not even anything to do with the lesson. Then they're having to remember, like, what am I supposed to be teaching and what am I supposed to be bringing out and what questions would help them think deeper about the topic. And then they're trying to like write down stuff and like take roll and take attendance. And whew, it's easy to make mistakes sometimes, huh? Especially when you're juggling a lot of stuff. Anyway, I don't try to be perfect in front of you guys. I never do. And you guys know I'm not. But just have grace for teachers. There's a lot that's going on here and here and here. And okay. Keep going. That was just sharing life. Okay. Well, have you guys ever had to like stand up and do a presentation in front of the class? Like that's hard enough, and all you have to figure out is how to take this and do that, which is hard at the beginning, right? Like that's hard. I get it. But just think of like adding a whole list and whew. Okay. So you got negative 2y. Keep me honest if something goes wrong, but with grace would be nice. How are we doing? Good? Sweet. You know what's cool? Is by following the system, we all should have the exact same work. if you went at it a creative way and you made a mistake, this is what Gab and I were talking about, went at it a creative way, it should have probably led you, like as long as everything's legal, if you go a creative way, it should lead you to the right answer. The only dilemma is if you make a mistake, who's going to be able to find it without having to redo all of your work? But if you follow the system, it's really easy to find a mistake. Kyle?
Can't you also divide the second one by 2?
True. True, but if that was the only variation, then all I have to do is check this creative step rather than having to like redo through the whole problem. Does that make sense? Yeah. But yeah, you could have totally divided everything by 2. Which means, as a divide all this by 2 and it should match yours. So it could be negative y plus 4z equals 1. But it should be an equivalent. Ooh, good math term. What's equivalent? Yeah, the exact same, just a multiple of. Remember, equivalent is the exact same, just a multiple of. For R2 and R3, okay, maybe I should ask you guys, what did you do? Did you multiply by 2? I guess you could have divided by 2. I would multiply by 2, just it's easier in my head. 4x plus 2z. Okay, 6y minus 24z equals negative 6. If someone had done it the dividing by 2 way, what could this be instead? 3y minus 12z equals negative 2. Or Kyle's like, you could have divided by 6, right? Or y minus 4z equals negative 1. Hey, that might be nice for my row echelon form in a second. Now what are we supposed to do? What's our system say to go for next? Our plan of attack. We got rid of the x. Go team. Now what? Get to the z by getting rid of the. Got it. I'm allowing you to be creative, and hopefully in being creative, you're just going to multiply everything by 3, but maybe if you had a different result, you might multiply by something differently. But negative 6y plus 24z equals 6. Then I have 6y minus 24z equals, what happens? Dang it. True or false? True, which is why you guys answered just a moment ago when I asked you the question using our new vocabulary words, consistent or inconsistent. You all, hopefully those of you that got it, answered consistent, because inconsistent is no solution, and that's going to happen anytime you have, what kind of answer? Yeah, a number equals 0 or a number equals the wrong number. 24 equals 2. No, it doesn't. Yeah, exactly, inconsistent. Whatever they gave you can't possibly come all together and intersect all at once. Now, there are different ways of being inconsistent. To figure this out, you would say, hey, can those two hit? Hey, can those two hit? But I'm not asking you what kind of inconsistent. If you have a false statement, just say no solution. We're done. But consistent, this one's easy. This one you just get an x. Oh, I already wrote it yesterday, didn't I? You get an x and a y and a z. You get a number and a number and a number. But these two, stink. You don't get a number for z, so you can't get a number for x. So you can't get a number for y, so you can't get a number for x. So what are we going to do? Ready? In your notes, if I were you. Ready in your notes, if I were you. Ready in your notes, if I were you. I would let z equal some constant a. Why? Well, in any of these examples, z can be anything. Don't get to the last step of z equals a number. It's not this case, so therefore there are infinitely many possible solutions for z. And x and y. But here's my question. I know that there are infinitely many solutions in this line. But my question is, does that mean all solutions, all points are intersections? No, it's fine. This one, all points, all numbers, all real numbers in that plane are going to be solutions, but this one is very limited. So what we have to do is say, okay, so infinitely many, but not all? Are there different types of infinity? Because there's infinitely many points, but that includes everything on and a bigger includes everything in space, and maybe a bigger infinity that goes to different dimensions? Whoa. So has anybody ever heard the argument? And it was from like a really cheesy Christmas movie from a long time ago in my childhood. Nuh-uh, yeah-huh. Nuh-uh, yeah-huh, nuh-uh. Nuh-uh times infinity. Nuh-uh times double infinity. In the movie, it was like, you can't have double infinity. Infinity is forever. You can't have double forever. Was the little girl right? No. You can't have double forever, and it's stronger than single forever. You can't have forever squared, and it's even stronger than double forever. Why? Well, that's one little baby example as to why. Anyway, so all that to say, what do we do when we get 0 equals 0? Forever! All points! We're done! No. We have to say all points, but only in this space. All points, but only meeting this condition. So Tony, I think you were the one that said it right. We need a formula that relates all the solutions and saying, okay, all the solutions, but only here. Yeah, it's going to go forever, but only here. Because of the picture you guys just saw. So whenever you get 0 equals 0 in a system of equations, guess what you're going to do? What did we just write down? Let z equal a. Because when you go to do your row echelon form, remember we were doing that yesterday? We would come over here and we would go to our row echelon form. It's a way of double checking and making sure you guys are doing this right. We would say, hey, let's steal this top guy. Ooh, this top guy, though, has a leading coefficient of 2. So to put it technically in row echelon form, we'd have to divide everybody by 2, whether or not you like it. So we could get x plus 1/2 y minus 3/2 z equals 2. Now you're like, ugh, I would have chosen the second equation because dividing that by 4 is nicer. Well, is it really? You still have fractions. But long story short, remember, a computer program, you just always use the first one, whatever. Computers can deal with fractions. We don't mind. We don't feel bad giving a computer or a calculator a fraction, do we? Isn't it like relieving to be like, here, you handle it? Okay, but in row echelon form, I don't just start with the 1x. What do I do next? I need the 1y. So I have to choose from these. Yesterday, weren't we going to choose the first and the first? Isn't that what we were choosing? The first and the first, and then this guy? But, wait. Okay, so choose this guy. Divide everybody by a -2. I need a leading coefficient of 1. So dividing by a -2, dividing by a -2, and dividing by a -2. There he is. Do I have a leading coefficient of 1 for the x? Yes. For the y? Yes. For the z? But yes, because what am I going to do? Z equals a. To finish the row echelon form, we need z. And if there are infinitely many, we say, okay, he's an a, he's a b, he's a c, he's a number. But now, what can we do that we have z equals a? Back substitute. So we're going to say, for our solution, yes, there is a z, but he can be any number. But if z is any number, if z was 1, y could be anybody. No. I'd have to plug in and figure out what y would be based on that 1. Or if z was 2, what y would be based on that 2. Or 3, what y would be based on that 3. So plugging in a, -4a, adding it to the other side, do you guys see why I'm going to say that y needs to be -4a minus 1? Whatever z is, y is now limited. There are only certain y's that go with all those infinitely many z's. And once I get y, guess what? There are only certain x's that go with those y's that came from that z. Now, some of you are like, I don't like it. I know. But in life, aren't there things we don't like? I think it was C.S. Lewis. Miss Gudermuth reminded me this morning. Mr. Carmichael also loves this quote. That said something to the effect of, God shouts in our pain, but whispers, and here's the word that I don't remember. God whispers in our joy, I think, but shouts in our pain. When everything's going well, it's kind of hard to see God sometimes and to feel him and to hear him, or to even care to look for him. But in our pain, where does almost everyone turn? In some way, shape, or form. Whether it's in anger, whether it's in comfort, whether it's in grief, it's in pain that everyone's like, I think there's something higher, whether or not I choose to believe in it. What is all that to say? We can learn the most sometimes in the things that hurt the most. It's just harder. Long story short, we have to solve it. But if we can learn how to program, maybe someday you'll be the ones telling the machines to do what you don't want to do. Coming back. So, x plus. Hang in there in the momentary pain. There's a verse that goes with that. Our afflictions are momentary, but they accomplish for us an eternal weight of glory. They don't feel momentary sometimes. If you plug in y, you get 4a minus 1. If you plug in z, ooh, isn't that a minus 3 halves? You guys keep me honest. The negative 3 halves times z, which is just a, equals 2. Can we do it? Yes. Do you like it? Maybe not. Sorry, too bad. So plus 2a minus 1 half minus 3 halves a equals 2. I can add a 1 half. 2 and a half is 5 halves. I can combine these guys. I'm going to make 2 a common denominator of 4 over 2 minus 3 over 2 is negative 1 half a. So therefore, my x, if you guys can double check my work, it'd be great. 1 half a plus 5 halves. Anybody tracking? Adam, what'd you get? Messed up the system. Has anybody else gotten there besides me? Are you sure? Well, maybe my x is wrong, though. Guys, remember, I'm not perfect. We had this whole conversation. So I plugged in x plus 1 half times y minus 3 halves times z. That's 3 halves a. That's easy. This is going to be 1 half times 4 is 2a, right? And 2a minus 3 halves, 2 minus 1 and a half is a half, right? Ooh, is positive a half. Positive a half. Good, 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 good. Thanks for letting me talk it out. Sometimes you just got to talk it out. So that'd be negative 1 half a.
Could you combine that to be 5 minus a over 2?
Yeah, you could. Adam said there are different ways of writing it because there is a common denominator. You could do negative a plus 5 over 2, or you could do 5 minus a over 2, all different variations, or. Math sometimes gets nasty like that because there are different ways of writing the exact same thing. We could totally go into a life lesson there too, but I'm not going to. We've already had a few today. But a way of being compassionate and understanding to others is realizing they might be saying the same thing in a very different way that you don't understand. But anyway, I just chose that one because it looked nicer to me. Are we good now? Go team. What do we do if 0 equals 0? Let z equal a. So how on earth, this was section 7.3a homework, and we're almost done with class. We still have, what, 15 minutes, right? Whew. Nothing crazy like the other day. Oh, no, that was calculus. I totally thought that they were done 15 minutes early. I was like, got to go, and they're like, we still have 15 minutes. I'm like, to go. Let's keep going. We still need to get to 7.3b. Adam, did this show up in 7.3b? Or 7.3a?
The one we just did.
This one. Okay. I thought this is where I split it up. Well, I thought I split it up earlier. Tony, this is for the end of class. So when class ends, go to Mrs. Bristol. Okay. This one starts with a note. Why? Because the example that you just did, didn't it look like the ones we did yesterday? There were 3 systems. There were 3 variables. There was one system. There were 3 equations, 3 variables. It looked just like all the ones we did yesterday. Nothing weird happened until you got 0 equals 0. What's different with this problem that from the very beginning you should be like, But how many variables? Ever since algebra. Should be 1, but maybe for you it was 2. We've learned how many equations do you need per number of unknowns? The same. 2 unknowns, 2 equations. 3 unknowns, 3 equations. Almost always true. And I will still say still true. But what if I was to say something like, hey, if you have negative 3 plus 2i, it's a complex number, equals a plus b minus 3i. One equation, how can you solve for 2 unknowns, a and b? You guys saw this one, it was a while ago. How is this possible? I just told you we need the same number of equations as the unknowns, and I gave you this and said solve for what? A and b. But can we do with this guy? Part is real, part is imaginary. So we can look at it and say, oh, but wait. In this statement, in this one equation, you're actually saying that -3, the real, has to match with A, the real, right? And what does 2I need to match with? The imaginary has to match the imaginary. The real has to match the real. They can't combine unless we're squaring or something that might make imaginary real, which is the whole other craziness of imaginary numbers. But even then, weren't there technically 2 equivalent statements to get 2 unknowns? It looks like one equation, but there were really 2. So how on earth am I going to tell you guys to solve number 44 if there are 2 equations with 3 unknowns? Follow the system. What? Follow the system. What's the system tell you to do? Eliminate x. We're going to start there. Nothing changes yet. Eliminate x. All right. What are you guys going to do? Divide everybody by 2 or multiply by -2? That's what I would do. Multiply by -2. Double check my math. -4x minus 6y minus 6z equals -14. X is gone. How's it look? It's a good idea because that's what the system tells us, right? R1, R2, eliminate the x's. R2, R3, well, we can't do that. R4, R5, eliminate the what? We can't do that. So we can't go eliminating y's because there's only 2 equations. We got rid of the x's. We can't go getting rid of more x's. We can't go getting rid of y's. So what are we going to jump to? What if I were to ask you to start writing row echelon? Could you give me a first equation? Yeah. Right? We'd come up here, divide everybody by 2. So you would get x plus 3/2 y plus 3/2 z equals 7/2. We have the first equation. We're good. Could we go the second equation? Yeah. We could divide everybody by 12, and we would get 1y plus 9/12 reduces, right? 3/4? Good. Good mental math. Equals 30/12. Keep.
What? Wait, 30 on the top?
Yeah, 30/12. If you go all the way, 6 goes into both 5 times. Good. 6 goes into 35 times, 6 goes into 12 5 times. Don't worry, guys. You don't have to do mental math. You could have literally just written 12, 12, 12, and then taken time and been like, yay, 1y. Take time to reduce 3/4 z. Take time to reduce 5/2. So what am I actually missing? Because I don't have another equation. But what was I doing in the last equation when I ended up missing, even though it had 3 equations? In the last example, there were 2 equations in the system that were equivalent. And so, ultimately, even though it showed 3, there were only 2 that were helpful because 1 was equivalent. So really, in the last equation, it was the exact same dilemma as this one. You just didn't see it because it looked better. Has the exact same dilemma. Had the exact same dilemma. It just looked differently because you were like, I can do my system, I can do my system. And then you went and you were like, oh, 0 equals 0. I can't do my system. But you can. You're just going to put in let z equals a. So whether you have 2 equations or whether you have 3, but one ends up not being helpful, you still just let z equal a. So now what? Plug it in, plug it in. When you guys go to plug in, isn't z the easiest one? Yay! All right, work backwards. But hold on, if you already solved for y, isn't it easy to plug in and subtract for y? Y is not bad, because Because if you, yeah, x is the bad one. So when you plug in, then you go ahead and say, oh, hey, 3/4 a, subtract. So it's going to be negative 3/4 a plus 5 halves. And remember Adam's thing about how you can then rewrite stuff? You could technically get little baby common denominators here by multiplying this guy by 2/2. That'd be 10/4. You could rewrite this to be negative 3a plus 10 all over 4. I'm not saying the back of the book does that, but it's possible. It could do something like that. Or 10 minus 3a over 4 means the same thing. And here we go. Why is Gavin gearing up? Because what do we got to do now? But what are we going to do? Solve for x. How? Well, subtract him and subtract him. Just got to plug in who y is and who z is. You guys go. You don't need me. I'll go, and then you can double check my math. Sound good? All right. That's what collaboration is for. Is it okay if I just subtract the stuff on the other side first and then plug in? I think I'm going to do that. I'm going to solve for x by subtracting stuff. So negative 3 halves. Okay. If I was doing this, I'd do it differently, but that's okay. All right. I get some common denominators to help me out. Negative 15/4 plus 14/4 is negative 1/4. Ha. And then 9/8 minus 3 halves. Ooh, let's get common denominators. 9/8 minus 12/8 would be negative 5/8. 9/8 minus 12/8. Oh, negative 3/8. What am I thinking? That's ridiculous. You guys got negative 3/8, right? Now, if you were getting common denominators, you could rewrite that by multiplying by 2/2 to be negative 3a minus 2 all over 8. I'm not sure if that's really tons better, but it's another way of writing it. I heard some people say, Do you agree with the whole thing? Sweet. So it's possible, huh? Here's the silly thing. What are you guys complaining about? Fractions, distributing, combining. Do you wonder why when you were younger you had a lot of fraction practice and a lot of distributing practice and a lot of combining terms practice? Because ironically, in math, as you keep learning and growing, sometimes the most basic things are the most annoying. Tony? Like to check? Technically, yes. And if, well, but wait. And if when you plug in, hold on. To the top equation, Tony, you would get a equals, right? Because the x would be gone, the y would be gone, the z would be gone. You'd have just a's, and you get a equals. Same thing with the bottom. But I think when you plug in, you wouldn't get a equals a number because it doesn't. You should get two true statements. Does that make sense? Showing the infinite nature, but saying, oh yeah, it works. So if you get a false statement, not good. Did that just change without me hitting it? Or did I hit something? Oh well, thank you, Jesus. Here we go. Another example. So, hold on, let me make sure I didn't skip 2 pages, because I don't know what just happened and how it just went forward, but all right. Okay, this is confusing. Where'd my page just go? Oh, I deleted the page. That's what happened. There he is. All right, all better. What do we have left? Okay, I'm going to dual screen. Oh, calm down. I'm going to dual screen it, and I'm going to show you the last 2 problems, which are basically homework helps, but homework helps for a purpose because they can be tricky. Homework helps for a purpose because they can be tricky. Ah, Rachel. See? We did see position in pre-cal. Remember? I mentioned it the other day. Anyway, I was mentioning to them because they had to use the position equation, except they actually, calculus kids are able to say, okay, cool. Then for any free fall, if you drop or if you throw an object, you shoot an object straight down or straight up, maybe you're doing like clay shooting or something. If it's free fall, like all that's is some sort of initial velocity and gravity, objects always fall the same way. And so in calculus, it's like, hey, let's start with gravity, which is a constant, and let's move backwards and talk about how fast velocity functions, and move backwards, talk about position. They're able to use this cool thing called an integral. But for you guys, sorry, we're not going to figure out where this guy came from today. You need calculus. But we'll just say it's a thing. This equation is a thing in free fall models, where you just have an initial velocity, maybe, well, an initial position, and gravity. So before we get to an example, really quickly, let me just identify stuff for you, okay? So A, technically acceleration in free fall models is going to be gravity, and specifically we say negative gravity. Gravity is a force just has a positive number, but we say negative because gravity is pulling everything down as opposed to like if you're sending something up, like throwing a ball up, that would be positive velocity, negative velocity as it's falling. Anyway, long story short. Gravity is a constant, which could either be negative 32 feet per second squared or negative 9.8 meters per second squared. Just depends on whether your measurements are in feet or in meters. This is like basic physics, just kind of showing you a formula. And don't worry, there's a reason it's in this section, and there's a reason why we're saying this will show you a practical application of using your math skills that we just did. V sub naught is a snazzy way of saying V sub 0, is a snazzy way of saying velocity at 0. This is what we call our initial velocity. And S sub naught is initial position. Now, don't worry. This might seem really scary. This might seem really scary. So to be honest, I'm going to pause a really scary one, and I'm going to go to the less scary example. Because this one should be a little less scary, and let me show you why. If you look at this picture, question, can we any statements, like add things up and set them equal to something just by looking at the geometric shape? What can we say right now? X plus Y plus Z, 3 angles in a triangle have to add up to, what else can we say? We need 3 clues because we have 3 unknowns. Who has another one? Good. X minus 7 plus Y, what did 2 supplementary angles have to add up to be? 180. And then 2x equals 180. Now hold on, is this the way we like to see systems? Oh, that's a mess. Okay, so let's rewrite it and make it nicer. We have x plus y plus z equals 180. Can't we move the 7 to the other side and get 2x plus y equals 187? And then let's move the 7 to the other side and then line this up. 2x plus z equals 173. Aha! How do we solve this? By solving the system. Okay, so solve, we need a system. To solve, we need a... What if they gave us 3 positions? Which is what exactly this problem does. They give you 3 positions, aka 3 points, an x, y. Well, we can even call it like x1, y1 if you want. Where was this object after like 1 second? Where was this object after like 2 seconds? Now, I'm just kind of pretending. Where was this object after 3 seconds? If they give you 3 locations, okay, now this is going to be a little weird. If you guys look at the equations, there aren't x's and y's. Well, that's confusing, but let me change all my x's with what the x is in this equation. Do you guys see who the x is in these equations? T. So it's going to be a T1 and a T2 and a T3 at a certain time. And do you guys see the y's aren't really y's? What are they labeled in these equations? S's. They're going to give you S1 and S2 and S3. What could we do if they gave us 3 clues? Oh, come on. If they give you S's and T's, what could you do? You could make a system of equations because, guys, what happens if you plug in S and T? A and B and S, and how many A and B's and S's are going to be left? 3. 3 equations, 3 unknowns, solve the system. But instead of X and Y and Z, what are you going to be solving for? A and V and S. See how it goes. Bye, cool kids. I'll see you on Monday. Use the example in the book and the odd on Calc Chat to help you out. But you're trying to get 3 equations with 3 unknowns, plugging in what you do know. Bye, guys. You guys stayed surprisingly awake today, though.